come to matter and start up, we are going to be considering the concept of logic. And logic can simply be defined as the study of correct reasoning. In a more formidable way, we can say that logic can be defined as a science of reasoning. It can be termed the what? The science of reasoning. Is the science of reasoning. And when we say science of reasoning, I am not trying to say that it is in the class of pure science or even philosophy. It's just a science on in its own class, basically. And there will be a need for us to understand what the term statement means in the logical context. What do we define as statement? What is statement? A statement is a declarative state sentence, which is to say a sentence that is capable of being true or false. Let me just say that a statement is actually a sentence or mathematical expression that can either be true or false, but it can be both. It can either be true or false, but it can be both. Meanwhile, I need to state it clearly that a statement or statements are always sentences, but not all sentences are what are statement. But statements are basically declaration. The moment you have any sentence that appear in form of command, in form of suggestion, in form of exclamation, such cannot be categorized as statement because we cannot allot the term true or false to it. Stand up, I can't say true or false. Are you coming? That's the question. I can't say true or false. But when it's a declaration, for instance, trees are tall, boys are good, fire is hot. These instances are referred to what as statement. Fire is hot, trees are tall, and the likes of them. These are referred to as what? As statement, because they are just declaration that we can argue. Do you understand? When we have a statement, then we can argue it. You can say, no, fire is not hot, fire is warm. It can be argued. Oh, trees are not tall, some trees are short. It can be argued. The moment it's in that state, then we can call such a sentence a statement. And that will lead us to the definition of what we call argument. Then what is argument? Since we said that a sentence is a declaration that can be argued, then what is argument? Then I need you to understand that argument is a collection of what? Is a collection of statements. The moment we have collections of statements, then we term it what? We term it argument. Is a listen of statement. It's a collection of statements of which is designated as a conclusion, and the remainder of which is designated as what? As premise. So in other words, what I'm trying to say is that argument actually comprises of a statement, but under the statement, you know that we have what we call the premise and the conclusion. What do we call the premise? What do we call the conclusion? Usually, actually, the premise of argument are intended to support or to say justify the conclusion of an argument. For instance, let me explain what I mean by justify the conclusion of an argument. For example, if I have a statement, let me say statement P to be there is smoke. There is smoke. And I have statements, let me say Q to be there is fire. There is fire in a way. Then I if I then say that there is smoke, there is smoke, therefore there is fire. Now, the premise on which I'm basing my conclusion is there is smoke. In other words, the term called there is smoke can be termed my what? Can be termed my premise, while the term called there is fire can be termed my conclusion. So I repeat, usually the premise of an argument are intended to support the conclusion of an argument. That is what it's intended to do. The enormous importance, the enormous importance of logic, and the truth is that logic is widely used in the field of mathematics, as you are doing now, as is used in the field of law for the argument purposes. If something like, if she is caught with a knife, then she must have killed his father. If the food is on fire, then the rice should have been cooked, of that nature. So it is actually used in the field of law. It is used in the computer science or computer engineering field, in the field of computer or ICT. It is as well used in the field of engineering, just to mention but a few. Yes, it is used in the field of engineering and the likes of them. Very, very relevant that it is needed for us to make use of the concept of logic in these fields and many more of it. That is the importance of logic. Then the definition of truth table coming, because I have to look into it proper. What do we refer to as truth table? Truth table is a mathematical table used in logic. It can be used to validate argument. Truth table. It is used in what? In mathematics. Or it's a mathematical table used in logic. That is called the what? The truth table. The truth table. Meanwhile, I could argue two statements. I can argue three statements. I can argue more than two statements. But in this class, we are going to be considering just two and three statements. If I have a statement P and Q, and when I have the statement P, Q, and R, what is the truth table going to look like? Basically, because before we can make any argument, there must be a truth table that represents a sample space for all the possible outcome of that argument before we can actually go into the argument. You have to know the possible outcomes of the permutation of several arguments can land us to. The reason why we need the truth table. Now let's consider truth table for two statements, say P and Q. Two statements P and Q. So if I have P and I have Q, then what is the truth table for it? I have true true, I have true false, I have false true, and I have false false. Now this I was able to generate from these are computer binary number PQ. When I have 1 1, I have 1 0, I have a 0 1, and I have a 0 0. So that my 1 means my true, and the 0 typifies the false. Just for easy comprehension. For easy comprehension. So that is that for truth table of two statements. But how does it look like when I have truth table for three statements? How is it going to look like? Now, when I have three statements, say P, Q, and R. P, Q, and R. How does it look like? I have my true, true, true. I have my true, true, false. I have the true, 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 false. I have the true, false, true. I have the true, false, then false. Then I have the false, true, true. I have the false, true, false. I have the false, false, true. Yes, and I have the false, false, and false. That is that for my truth table for three statements. You can also try to compute it using our binary code, where you have 1 1 1 1 1 0 1 0 1 1 0 0 0 1 1 0 1 0 0 and 0, then um, 0 1 is 0 is 0 0 1, and obviously 0 0 0. So you can have this also just to enhance your comprehension of how we derive the truth table, basically. Then there's a quotient need for us to construct the truth table for our connective. But first of all, what are connective? What do we refer to as what? As connective. This connective in a way, are prepositions that are used in amalgamating or bringing together two or more statements before we can generate a conclusion. That is what we refer to as what? As a preposition, basically. So, and according to this class, we're discussing connective and connective or connective implication, the connective by implication, and the negation. These are the 5 types of connective we're going to be looking at in this class. Then we're going to be constructing truth table for each of these connectives. Truth table for each of these connectives. Starting with the connective or. Now the connective or is typified by um, a symbol like V facing down, and there is a condition attached to it. Then for the truth table, let me first of all give you the first thing I'm going to construct before we can have the table is something of this form. The statement P and Q must always be given. Then I have P or Q given as well. So your truth table, your typical one that we have initially, true, false, the first true, and the what and the false is given actually. So how do we get our table? What is the condition that I have to consider before I can generate this table? What is the condition for the or connective? Now, sorry please. Given a statement P and Q with respect to our or connective, the two statements are true when, or better still, if at least one of the statement is true. At least one of the what of the statement is true. If at least one of the statement is true. What do we mean by that? When I consider my truth table and I try to combine the two statements together, if at least one of these two statements is true, then the outcome will definitely be true. First of all, the first one says true, true. That is true. True, false, true. False, true, true. False, false is false because it said at least one of the statements will be true. So this is what this is the truth table for all connective. Then for and connective, what do I have? I have my and connective. The and connective is symbolized by um, inverted P, inverted V of this form. Is otherwise known as our conditional, as conditional, conditional. Our or is otherwise known as, sorry, I mean to say um, conduction. I mean to say our and is known as conduction, otherwise known as conduction. Why our or is known as disjunction. Disjunction. Our or connective is known as disjunction, otherwise. So the first thing you are going to construct is your truth table. Your truth table, statement P and Q, so that our statement P and Q our statement P and Q are the first thing we're going to be considering. I have my truth, truth. I have my truth, false. I have my false, true. I have my false and what and false. Then the conjunction P and Q. This there's a condition backing up the and connective, and it states that given a statement P and Q, the two statements will always be true if and only if both statements are true. If and only if what both statements are what both statements are true. The moment this happens, then you can what you can easily allot truth to the conjunctions. The conjunction. So through will eventually give you through. True false will give you false. False true will give you false. And false false will give you false. Because the condition says that the two must be true before you can allot a true outcome to it. A true outcome to that is for the and connective as well. So the next one is the implication. The implication, which is otherwise known as the conditional. It has a symbol of this form like an arrow, and its condition says that it is always true. Given a statement P and Q, it is always true, except when true statement implies false. That is going to be false. Otherwise, it is always true. So when I have my table of this form, my truth table of this form, I have my P, I have my Q, I have my true, I have the true false, I have the false true, and I have the false false. I have the false false. So because of the condition that is actually underlying um, P implication Q, then true will be true, false will be false, because that is the only time it will be false. False true will still be true, and false false will be true. So therefore we have that to be for implication. Then the next one is called by implication. By implication or by conditional. Or by conditional. By conditional. Sorry, please. The by conditional. Now it's symbolized by two-edged arrow in quote, and its condition states that it is always true when true implies true and false implies false. When true implies true and false implies false, it is termed true in that note. I have P, I have Q, I have P by implication what? Q. P by implication Q. True, 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 false, false, true, false, and false. So um, the condition is a state. True will just be true. True will just be what? True will be true. True false will be false. False true will be false. And false will be what? True. Because it says it is always true when true implies true and when false implies false. That is the only time that it will be true and pick up the outcome of false as well. The last of it is termed the negation. This one seems to have various symbols as it ranges from this to prime to something. This it's all negation, depending on which one you are interested in. But it's just the direct opposite of a given statement. It's the direct opposite of a given statement. For instance, I have my table of this form. I have P, I have Q, I have negation. I want to just vary the symbol. Negation Q. True, true, false, true, then false and false. Negation of this will give us false, true, false, true, and true. Then I have false, I have true, I have false, and eventually true. That is the negation. That is what called the negation table. So with this knowledge that you have just acquired, you can easily construct a truth table for any given statement, no matter what the case may be. And you can also construct a table of all connective for 3 or more statements, provided you have the basic and you understand the basic knowledge that you have just acquired using just 2 statements, P and Q. Let's take one example before we round up the class. For instance, you are expected to we are expected to construct a truth table for the statement. Let's say that you are expected to construct a truth table for the statement. Say P prime implication Q, or let's say that P and Q prime. How would it look like? Your job is just to create a logical a truth table for this statement. How is it going to be done? It's simple as what you know. You don't need any other additional information to get this solved. Just work with the one you have acquired. I have my P first, my truth table. I have my Q followed. I have my true, I have my true, false. I have my false, true. And I have my false, false. Please keep that in mind. Then followed by my P prime. What does my P prime says? You know it's negation. False, false, true, true. Then I have my P prime implication Q. And I know you know what that stands for. Your P prime implication Q, what does it say? It's saying that your implication says that it is always true except when true implies what? When true implies false. That is the only time that is what is to be false. So can we come together? False true will give you true. False false will give you true. True true will give you true. True false will give you false. Then followed by your P and Q. P and Q. What do you have? True true will give you true, and others will eventually give you false, because we know that it has to be true with respect to connection and before it can be, both have to be true before it can be true. So P and Q negation means that this is false, this is true, and this is what this is true. So you can easily tag this place A, tag this one B, so that you write A or B here eventually. So when you do that, what do we have? We have A or B with or. Don't forget, Are Connective says that it is always true if at least one of the statements is true. Now, for that case, you have true, false to be true, true, true to be true, true, true to be true, false, true to be true. Hence, the outcome is all true, and that is referred to as tautology. Tautology. Tautology, actually. So we have to keep all of this to mind. If all was false, it's called contradiction, and if it's a mixture of true and false, it is referred to as fallacy. Okay, we have just come to the end of the class. I hope you are able to gain one or two things from this class. Please ensure that you subscribe to this channel, turn on the notification button, share with friends and family, and expect the next video. Your comment will do us a lot of good and gives us perspective to making a better output or bringing a better output. Thank you for being a part of this.